2025 A-Level Combined Mathematics Paper 1 Part B, question number 17, Part C. Part A of this question was solved in a previous video, link in the top right, and Part B of this question was also solved in a previous video, link in the top right. Part C of this question has two simultaneous equations that we have to solve, and these simultaneous equations are related to trigonometric functions. It says, solve the following simultaneous equations for x and y, and the first equation says, sine inverse of the square root of x is equal to cos inverse of the square root of y. The next part says tan of tan inverse of 3x minus tan inverse of 2y plus tan of tan inverse of 3i minus tan inverse of 2x is equal to 1. Now, the way we can solve this is to call this equation 1, call this equation 2, and find an expression from equation 1 that we can then substitute into equation 2 in order to get our answer. Now we can see that here sine inverse of square root of x is going to be some angle, and that angle is the same angle as cos inverse of square root of y. So let's suppose let alpha be that angle which is the sine inverse of the square root of x and is also equal to the cosine inverse of the square root of y. Now this means that we have some kind of triangle like this, that if you consider the triangle and you consider, let's say, the hypotenuse is equal to 1, let's say this angle here is alpha. From the fact that alpha is equal to sine inverse of square root of x, when we take the sine of both sides, sine alpha is going to be the square root of x. So therefore, this side length is going to be the square root of x. If we then consider cos inverse of y being also equal to alpha, and we take the cosine of both sides, we can see that cosine of alpha is going to be equal to the square root of y. Therefore, this is equal to the square root of y. Now from this we can see, if we square both sides, we can see since sine of alpha is equal to the square root of x and cosine of alpha is equal to the square root of y, and we know that sine squared of alpha plus cos squared of alpha is equal to 1, we can see that square root of x squared plus square root of y squared is equal to 1, and thus x plus y is equal to 1. Now from this we can also see that y is equal to 1 minus x, which we could use later. I'm going to call that equation 3, and we'll see if it's possible for us to use it later. Now if we go up back to equation number 2, equation number 2 shows us this relationship that we have right here, and we can see we have the tangent of some tan inverse values, and we can see we have tan of one value, actually one angle which is the tan inverse of one value minus another angle which is tan inverse of another value. Now if we consider the expression for tan of one angle minus another angle, we know that the tangent of an angle A minus an angle B is equal to the tangent of A minus the tangent of B divided by 1 plus tangent of A times the tangent of B. What I'm going to be doing now is to use this thing, substitute in the two values that we have up here, this expression for tangent of some tan inverse values and this expression for tangent of some tan inverse values. We're going to convert it into this form, both of them, and then we're going to equate them to 1 and simplify. So if we take 2, we can take 2 and we can simplify 2 into, if we consider the first one, we have tangent of tan inverse of 3x minus tan inverse of 2y, which we can turn into tangent of tan inverse of 3x minus tangent of tan inverse of 2y divided by 1 plus the tangent of tan inverse of 3x times the tangent of the tan inverse of 2y plus the other bit, which we can see is the tangent of the tan inverse of 3y minus the tan inverse of 2x, which if we write down similar to this one, we're going to have this expression plus another expression which I'm actually going to write on the next line, plus another expression which is again going to be of this form. It is going to be the tangent of the tan inverse of 3y minus the tangent of the tan inverse of 2x divided by 1 plus the tangent of the tan inverse of 3y times the tangent of the tan inverse of 2x. So we're going to have this and these two added together, this whole expression plus this whole expression is equal to 1 based on the equation that we have, equation number 2. Now if we substitute into here, the tangent of tan inverse of 3x is 3x, the tangent of tan inverse of 2y is 2y, this is going to be 3x, this is going to be 2y, and over here as well, the tangent of tan inverse of 3y is going to be 3y, this is going to be 2x, this is going to be 3y, and this is going to be 2x. So if we substitute, we can see that therefore what we're going to get is going to be 3x minus 2y divided by 1 plus 3x times 2y, which is going to be 6xy, so 1 plus 6xy plus the second expression, which is going to be 3y minus 2x, so 3y minus 2x divided by 1 plus 3y times 2x, which is going to be 6xy again, so 1 plus 6xy is equal to 1. Now we can see from this that if you take this common denominator and you take the 1 plus 6xy to the other side, we're going to get 3x minus 2x, which is going to be x, plus minus 2y plus 3y, which is going to be y, so plus y, equal to 1 plus 6xy. Now here we know from 1 that x plus y is equal to 1. We can see x plus y is equal to 1, and therefore this thing right here is equal to 1. Now this is going to be equal to 1 plus x times y, 6 times x times y, and we know y is equal to, from equation number 3, 1 minus x. So y is equal to 1 minus x. So we can say we got that from equation number 3. So now we have 1 equal to 1 plus 6 times x minus, actually 1 minus x rather. So now with this we can see that 6 times x times 1 minus x is equal to 0, meaning that x is equal to 0, or 1 minus x is equal to 0, i.e. x is equal to 1. So we have two solutions, x equals 0 or x equals 1. Now considering equation number 3 again, y is equal to 1 minus x, and due to this, from equation 3 we can find the values of y as well corresponding. From 3, since y is equal to 1 minus x, for x equals 0, y is going to be equal to 1 minus 0, which is 1. And for x equals 1, y is going to be equal to 1 minus 1, which is 0. So therefore, the two solutions are x equals 0, y equals 1, and x equals 1, y equals 0. So these are the two pairs of solutions that we can have for these set of simultaneous equations. And that is going to be all for this question. Finally, considering the marks awarded for this question, at the start, when you relate an angle to this and then you see that the sine of alpha is going to be the square root of x, cosine of alpha is going to be the square root of y, and you use the relationship that sine square root of alpha plus cosine square root of alpha is equal to 1, you get 5 marks, and then substituting in the value of sine alpha and cos alpha, when you get that x plus y equals 1 or y equals 1 minus x, you get another 5 marks. Now after this, when you get the second equation and you substitute in the values like this, you use the fact that tan of a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. You substitute in and you get this expression right here, 3x minus 2y divided by 1 plus 6xy plus 3y minus 2x divided by 1 plus 6xy equals 1. You get 10 full marks. After that, when you simplify down to get this expression and you substitute in equation number 3 in our case, to write y in terms of x, or you could have also done x in terms of y, you get 5 marks. After that, when you find the two values of the two solutions that you can have, x equals 0 and in this case x equals 1, or if you did it with y, you would find y equals 1 and y equals 0. For finding these solutions, you get 5 marks. Now after this, when you finally find the corresponding values of y or x, depending on which one you did first, and then you write down the final two solutions, which are x0, y1 and x1, y0, you get a final 5 marks. And that is going to be all for this question, and in fact all for the pure mathematics paper. So that's the end of this video and the end of the pure mathematics paper. If you want to check out the applied mathematics paper, click this link in the top right. This is the first episode of that series, and that's going to be all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.